am Hoàng Vo, one of the PhD fellows of the Urbanizing Delta of the Works project. Specifically, we focus on the roles of strategic data planning process. We aim to better understand the role of the process in supporting transformation towards more sustainable delta. My PhD program, specifically, I took the Mekong Delta Plan established in 2013 as my central input for the whole analysis. The main question we raised here was to what extent does such plan enable the consent among the stakeholders over some strategic choices or priorities or innovative solutions or innovation, and whether or not such consent is sufficiently able to travel to the implementation phase. And what kind of characteristic of the plan will play a role of maintaining this consent over time. As my PhD research adopted the SDP, which is visualized as the hourglass framework, then it basically is a qualitative research. I adapted in my research some basic qualitative methods that engage with the policy development process, in particular the ongoing strategic delta planning processes, such as I made interviews with some key informants who are sitting at the high political level in the Vietnamese political system. For example, at ministerial level, such as Mart Monray, some advisors at this level. At international level, for example, World Bank, GIZ, IUCN, and some key national experts, etc. As the main methodology, I used the literature review, a case study, and for some more particular case studies, I employed more specifically multiple stream approach, the Millennium Assessment Framework, or the historical review via the lens of social construction of technology in order to further analyze some selected innovations. For example, the multiple stream approach was used to analyze the convergence or divergence of agendas set by the MDP and by the policy actors in Vietnam. The other was used to analyze some selected innovations like floating rails, room for the river, stream mangrove integration model, or lotus farming as an innovation. So based on which we drew some main lesson learned. For example, the key lesson learned we draw is about the SDP process. So we found that the SDP has traveled well to and in Vietnam. Although this process takes time, but the SDP has at least changed the mindset of political actors in Vietnam. We analyze some soft aspect of the implementation of the SDP, because the hard implementation is very difficult to take place. And at the end, we found the hourglass framework as our main analytical framework was useful, at least in the Vietnamese context. As for the innovation itself, we found that innovations play a role of a consent builder because it can bind the stakeholders. The most important characteristic of innovation we found to bind the consent and to maintain the consent is its multifunctionality. And we also saw the grassroots acceptance of stakeholders towards some analyzed innovations. And also, last but not the least, among others, we see the co-evolve process in the planning process between the strategic delta planning and the Vietnamese political planning process. But some aspects still require more integrated conceptualization that span across many domains. Thank you, and I will see you in the conference.
The Mekong Delta is one of the largest deltas in the world, and it is inhabited by about 20 million people, and it's producing food for almost 200 million people. The Mekong Delta is subsiding, but the amount of subsidence and the exact causes of subsidence are still unknown. What we see that there's a very high increase in groundwater use, and we know that excessive groundwater use can cause land subsidence. The question is how much land subsidence is actually caused by the increase of groundwater use over the past 25 years. We built a large 3D hydrogeological model of the Mekong Delta, in which we can simulate the groundwater use and extraction of the past 25 years. And we use that simulation to calculate the amount of land subsidence caused by this groundwater extraction. On the left side we see the hydraulic head of one of the aquifers in the model, and on the right side we see cumulative subsidence as a result of ongoing groundwater extraction. And then when we go through the model, we see that there's a gradual increase in hydraulic head drop, and then we see an increase of the cumulative subsidence.
This is a nice example of what happens when you are extracting groundwater. So this used to be the old surface when the well was built here. And now we see that the surface level is at least 30 centimeters lower.
At the start of the modeling period, the hydrogeological situation of the delta was actually in a rather undisturbed state. And if you talk about land subsidence caused by groundwater extraction, there wasn't hardly any of that 20-25 years ago. With the high subsidence rates that we see at present, the delta will get more vulnerable to flooding, and there will be salinization in the surface water and in the groundwater. And this is putting pressure on the agricultural system in the delta, but also of course on the livelihood of the people living there. During our trips in Vietnam, we closely work together with our Vietnamese partners and co-researchers, and I think it has to be a joint effort in order to save the delta from real drowning.
Hello, I'm Nadia Naushin, PhD Fellow of Core Bangladesh project. In this video, I'm going to present few glimpses of my research work. In Core Bangladesh project, the leading principle is that a bottom-up approach is required to select, showcase innovative and smart technologies and infrastructure in a real-life context through active participation of local communities considering economic and socio-cultural aspects. The research was conducted in Sirajganj, one of the most flood-prone urban areas of Bangladesh, yet very representative of peri-urban region in the floodplains of the big river Jamuna in Bangladesh. Also, the hotspot in Bangladesh Delta Plan. Flood and water logging are the major disasters of this area. To study community resiliency, specific households are selected from this area, taking into account the vulnerabilities of the assigned households. This study offers different innovative small-scale flood mitigation technologies such as amphibious living unit, amphibious sanitation unit, retrofitted house, flood-proof seedling bed, and green soil bag in order to reduce the flood risks and enhance community flood resiliency. Bottom-up approach and community-based participatory survey was conducted through focus group discussion, interview, workshop, etc. A baseline study report of the study area was developed using historical records and a background study of the area. Besides, informal meetings were conducted with government officials. In order to make testing grounds more effective, several lessons learned from Core Bangladesh will be adopted in the Urban Demonstrators project. Stakeholders and end users should be involved from the start of the process development, testing and demonstration, where participatory approach on day-to-day use of technologies should be focused. Detailed performance analysis of these technologies considering technical, social, economic and environmental aspects should be conducted through continuous monitoring during operation of these technologies to ensure the sustainability of these technologies. Local government authority should be involved during tendering system to keep the process transparent. Utilization of local labor, local materials and local technology should be appreciated. End users should be financially engaged via an out-of-pocket contribution to ensure that they stay committed during the whole process. The individual technologies should have a minimum scale or number of test samples to achieve a more robustness in the appraisal of outcomes. Thank you.
Welcome to the story of breezing. What does a breeze do? Provides a connection between its two sides. Exactly. This research is about connecting adaptive delta management with the adaptation decision-making of actor communities. ADM is about deliberately exploring future uncertainties and preparing for a variety of possible developments. Bangladesh provides a starter with its Delta Plan 2100. It focuses on the general uncertainties in physical and socio-economic conditions. However, the uncertainties in the way local communities may adapt to uncertain conditions and policy measures under a variety of future circumstances are yet to grasp. And history demonstrates that these uncertainties can have serious consequences on the effectiveness of such a top-down planning approach. My research focuses on getting better grip on these uncertainties. How have I done this? I organized several workshops with mainly rice, integrated and shrimp farmers in polders in the southwest coastal Bangladesh as shown on this map. I went to the farmer communities and asked two questions. Why did they make certain decisions in the past? And what would they do under different future context and why? Based on these workshops, I captured the farmers' decision logic in conceptual and quantitative models. I actually developed two modeling approaches. First, I used cognitive mapping. And you see, this gets very detailed. And therefore, I developed an alternative approach based on the motivation and ability framework. This is more aggregated. Informs policy adaptation with livelihood adaptation pathways of local community. Moreover, I could easily develop a pilot quantitative version for it. Using this model, I explored what the plausible future adaptation decisions would be for different scenarios and different farmer groups. In conclusion, what are the key messages from this work? First, uncertainty in local community adaptation matters. Second, a participatory approach of joint learning and future exploration by policymakers and local communities is of utmost importance. And third, scenario workshops and the modeling approaches I developed are ready to support such joint learning. Thank you.
Badrul Hassan. I am doing a PhD at Utrecht University. my pitch is about Community Management Plus model for the governance of rural drinking water systems. The suboptimal performance of rural drinking water systems in developing countries is largely attributed to the lack of efficient governance, because governance models based on either the market or the state have often failed. Since the 1980s, community management has been widely adopted as an alternative in many developing countries. However, evidence shows that community-run drinking water systems often fail as well. Community needs the ongoing financial, technical, and the organizational support from external entity. This particular approach has been coined as Community Management Plus. Community Management Plus model means the system whereas communities run their drinking water system in collaboration with external entity, for example, public agency, local government, or NGOs. For Community Management Plus model to succeed, firstly, collective action among the community members, and secondly, collaboration between the community members and the public agency must be arranged for. In my research, I have looked at what it takes for the community management model to work. Literature on common pool resource helped me to find out the potential variables. With regard to the collective action, in an empirical study of ponds and filter governance in Bangladesh, I find that group size, heterogeneity of endowments, locally devised rules, interdependence among the group members, high level of user dependence on the drinking water system, and the presence of collaboration with public agency have positive impact. Regarding the collaboration between the community members and the public agency, I find that trust, transparency, and inclusive decision making have positive effect. I also looked at the form that the plus in Community Management Plus could possibly take. Particularly, I studied the form and the impact of NGO intervention in support of community management of managed aquifer recharge system in Bangladesh. I find that NGO support tend to focus on long-term requirements for the community governance over the requirements of day-to-day collective action. I also find that NGO activities seem based on applying the standard approach to training and awareness building, and less focus on empowering the communities to craft their own solution. Therefore, I end up recommending that when attempting to organize a collective action, both NGOs and the commissioners of the project need to engage more explicitly in learning what works and what does not. To conclude, I am confident that the potential of Community Management Plus is worth looking into with more details and precision. I hope that some of you will pick up the challenge and join me in my effort to craft the better ways to improve the delivery of safe drinking water to place and the people that it did most. Thank you for listening to me.
My name is MD Anaduzzaman Kadul and I am from northern Bangladesh, where arsenic was first detected in 1993. In Bangladesh, over 50 million people are exposed to dangerous levels of arsenic concentration in their drinking water that greatly exceed the World Health Organization guideline. Chronic exposure to arsenic causes a wide range of illness, including cancer and skin lesions. Growing up, I witnessed people suffering from drinking arsenic-contaminated water. I have since dedicated over 10 years of my career working on arsenic mitigation. During my 4-year PhD journey at the TU Delft, I have developed a novel arsenic removal technology. Why develop a new technology? Well, the problem is that conventional groundwater treatment uses a combination of aeration and sand filtration. This is effective for other groundwater contaminants, but not for arsenic. I envision that in order to remove arsenic, we start using the iron that is naturally present in the groundwater. In groundwaters, the iron will form rusty flakes after exposure to oxygen. These flocks have a high dissolved arsenic uptake capacity. However, when oxygen concentration are high, this uptake is very limited. The reason is that iron oxidation is very fast, whereas if it were slower, the uptake of arsenic might be more effective. The idea of my PhD is, therefore, to delay iron oxidation by introducing anoxic pretreatment. Anoxic means without oxygen, so without air. I tested this concept in a pilot study in Bangladesh with an anoxic storage tank added prior to the water treatment. We found that arsenic removal was promoted and that more arsenic could be removed by the same amount of iron in the groundwater. This new treatment method has advantages over existing solutions, which are energy intensive, consume chemicals, and require expert knowledge, making this new method more sustainable for vulnerable communities. Do you want to learn more? Well, for more details, I invite you to have a look at my open access publications. Thank you.
Hi, I am Santosh Kumar and I am a PhD candidate at Delft University of Technology. My topic of research is prediction and visualization of arsenic-free aquifers. The goal is to visualize arsenic contamination, especially to predict safe water sources in arsenic-affected areas. The goal of the study, the location for the study conducted was in my home village, Bakhurapur in Bihar. But first, I would like to tell you my story. I used to be a primary school teacher in Bakhurapur. One day, I saw people drilling near the roadside. I wanted to know what they were doing, as I knew one could not mine for gold there. This investigation was related to arsenic. This incident led me to meet my PhD supervisor. And his words, "I think you should utilize your knowledge of geology," were an eye-opener. I resigned from my job and committed to learn about arsenic pollution and applied for a PhD position in Delft. Arsenic, a metalloid, is well known for causing pollution in drinking water, leading to serious health problems. But what causes the release of arsenic from the sediments? Let me explain. The secret of arsenic release lies in the oxbow lake and the deposition of plant remains. Hence, in our study, we explored, modeled, quantified, and calculated the amount of arsenic in an oxbow lake using geomorphology, sedimentology, and remote sensing technique. The satellite images were used to calculate floating and submerged plant deposited in an oxbow lake. The organic carbon of this plant is used by anaerobic bacteria that release arsenic from the groundwater. The extraction of groundwater by hand pump well creates pressure gradient, facilitating arsenic to reach the drinking water sources, which puts people at risk. These research results can be helpful in estimating vitality of the problem and help policymakers creating mitigation strategies. If you want to know more about the scientific techniques involved in my study, they can be shared on request. Thank you.
I'm Dr. Rebecca Sapu. I graduated from Wageningen University. I work with the Public Administration and Policy Group. I work on the Waterhouse project under the EDW2 project. Now, in my project, I co-produce weather information service by integrating the local knowledge of farmers and then scientific model together. Now, in the Netherlands, there are lots of water available because of the Delta region. But the case of Ghana is different because of hydrological construction on the Volta Lake and then also climate change and variability. So because of that, water is not readily available in the Volta Delta as it is compared to the Netherlands. Now, when I started my PhD project, I decided to find out how farmers are coping under the variable weather condition in terms of decision making. Here, I realized that they try to make efforts in combining their local knowledge to make strategies concerning decision making for the farming season. But due to variable climate condition, their decision making strategies are not what adaptive. In view of that, I decided to interview farmers to collect data on their local knowledge, their local prediction, how they predict the weather every day. Here, I will talk about the fact that farmers see the bird, the shape of the moon, the sunlight, the intensity or the pattern of the wind. These were stories that existed in the local farming community in the oral form. But I collected this information, digitalized it into a web-based app. Now that was not all. I gave farmers a rain gauge and trained farmers how to use the smartphone. This idea was only limited to few farmers, especially the youth, who were able to use smartphone by then. So at the end of the training, farmers and I co-designed the interface of the web-based app, and then we decided on how to report on the information. So each day they look at the sunlight or whatever indicator they see, maybe the croaking of the frog, and then they use the web-based app to send their information. At the end, we collect this information and then put it in a pie chart. They decided in their own way that understanding uncertainty in forecast can be done with a pie chart where we use different colors, and the bigger the size of a color, for instance red, it tells that okay, there's a possibility that there's going to be rainfall. And when they see blue as the sign of the on the pie chart, it tells that there's going to be less rainfall or no rainfall at all for the next day. We do this on a WhatsApp page and a WhatsApp platform where every Thursday we meet and discuss as farmers and experts discuss the outcome of the weather. This research was carried out in 2019 throughout the farming season. And at the end of the day, farmers gave various testimony about how it supported their decision making, how they even learned that their own local knowledge is relevant to scientific forecast. Ladies and gentlemen, this is what I did in the Waterhouse project in Ghana. Thank you very much for your attention.
My name is Nurjan Glomsen, a PhD student at TU Delft with the top water reclamation for industrial use in Maputo, Mozambique. This topic is of interest because I live in an area in Mozambique where there are challenges regarding clean water supply for different purposes, such as domestic, industrial, agricultural, among others. The challenges arising from water scarcity and stricter regulations on wastewater discharge increase the interest in water reclamation. Looking at the industrial perspective, reclaimed water compared to surface water can be more attractive source due to its consistent quality and availability. The aim of my research is to identify possible uses of reclaimed water for industries in Maputo and suggest technological options for its implementation. Two main options were identified for using effluent from wastewater treatment plant. One for the construction industry and the other for cooling purposes. Pilot tests were conducted to evaluate if wastewater treatment plant effluent can be used for construction industry and what water requirements are needed for industrial cooling purposes. The main results show that the quality of reclaimed water for concrete mixing is adequate for stress development of concrete blocks. In terms of treatment, this requires only a disinfection step to protect the health of the workers. Furthermore, thermal power plants and data centers can make use of the effluent for cooling, as they both use similar cooling towers. For this usage, post-treatment is necessary to soften the water by using ceramic membrane microfiltration. If implemented, the water reclamation for industrial applications will increase the total available water supply, substituting drinking water where appropriate, and preserve the health of waterways, wetland, flora, and fauna.
My name is Selma Janeiro, and I'm doing my PhD at TU Delft, and my topic is in water reclamation for irrigation in Maputo, Mozambique. This topic means a lot to me, since my background is in agriculture and water management. Agriculture is an activity that contributes to livelihoods and of large part of population of my country, and it's an opportunity to survive the socio-economic distress in urban areas. Fresh water is a scarce and competitive resource in urban area, and this makes wastewater an alternative source for irrigation in peri-urban areas where water is limited. The benefits of water reclamation are increased water availability, nutrient recovery for agriculture, and additionally, environmental protection. Wastewater is widely used, treated, partially treated, or untreated in many parts of the world, and this situation is similar in Maputo. Let me explain this. The wastewater treatment plant in Maputo treats only 10% of its wastewater, and its effluent is widely used for crop irrigation, despite the plant not treating the wastewater adequately. In my research, I have assessed the risk of irrigating with wastewater in lettuce in the Influent Valley in Maputo, and I found that irrespective of irrigating with a water source, similar E. coli concentration were found in lettuce, which raised the possibility of other sources of contamination, such as manure application and crop handling. Therefore, I'm also assessing the effect of solar radiation on E. coli disinfection and E. coli contamination along the supply chain from field to market. In addition, I'm also assessing the amount of nutrients that can be recovered from influent wastewater treatment, because recent studies in Maputo showed that there is a potential to recover 500 tons of nitrogen per year for agriculture purposes. The results of this research will help to reshape the current status of water reclamation for irrigation and better inform the areas of improvement to enable secure water reclamation in Mozambique and across sub-Saharan Africa, resulting in development conditions of local agriculture farmers working in those areas. If you would like to know more, please feel free to get in touch. Thank you.
Hello everyone, my name is Lê Minh Trường. I am a PhD researcher in NTI project. The NTI project is a collaboration project between Wageningen University and Van Lang University. The overall aim of the NTI project is to enhance sustainable industrial development by optimizing industrial freshwater use in the Vietnamese delta areas through technical institutional innovations. We believe that technical innovation cannot be fully implemented in practice without institutional innovation. Hence, NTI has 2 PhDs. One deal with technical innovations, we call Work Package 1, and one deal with institutional innovation, we call Work Package 2. Herewith, I'm talking for Work Package 1. The first achievement of Work Package 1 is the application of data envelopment analysis and introducing it as a useful method for various users to assess the current industrial water use efficiency at company level. The user can be the governmental agencies, the industrial zone authority, or the industrial companies. The input required by the method are things within the arm of them. For example, monthly water use, contaminant concentration, number of labor, production capacity, and the rented area of the company. This method attracts a significant number of relevant stakeholders during our entire final workshop. The second achievement of my study is that I used the mathematical programming to design a water network for one of our selected case studies. This is an industrial zone in Mekong Delta, and the modeling network showed that by interconnection, individual companies can gain better benefit in terms of economic saving and minimizing environmental impact. Lastly, my study used ion exchange and constructed wetland as a method for upgrading quality of treated effluent at 2 industrial zones. Ion exchange show its efficiency in removal of unwanted contaminant, and the upgraded effluent can meet the required standards for domestic reuse. This result attracted attention of the industrial zone owner, and I got an offer from them for further collaboration and put it into practice at the industrial zone. The wetland study is still in progress with strong support and expectation from the industrial zone owner for further result. As mentioned above, this technical innovation will not be easy to be applied in practice without supporting from institutional aspect, and the impact of institutional aspect is introduced in detail in the study of my colleague in Work Package 2.
Hello everyone, my name is Trần Thu Trang. I'm from Vietnam. I'm a PhD student under the entire project. My research focuses on governance innovation in order to implement technical innovation to achieve water efficiency in industrial zones in Vietnam. The main concept of my research is institutional capacity approach. In order to achieve the goal of the research and also to adapt with the context of Vietnam, very top-down political system, we add one more capacity to the institutional capacity framework, each is regulatory framework capacity. We focus on the major level with describing and analyzing the capability of an organization like industrial zones or governmental organization to engage in problem solving and subsequently develop the shared strategies for enhanced water use efficiency. However, we also integrate the macro level element, in particular the system of rules, norms, and values. We consider the institutional setting related to the centralized state of Vietnam. We play with the general framework and generate 3 specific frameworks for different purposes. The first highlight is to understand the institutional capacity of industrial zones under the centralized state system of Vietnam. We found that all 4 capacities of the industrial zones are co-chanced by the centralized state of Vietnam, in which the regulatory and knowledge capacity are limited, relational and mobilization capacity are not optimal. There are also lack of detailed guidelines, standard, and regulation to support industrial zone to follow water efficiency in practice, for example, wastewater reuse or rainwater harvesting. The second highlight As you know, in 2018, the resolution number 2 and decision number 2129 from Ho Chi Minh City People Committee were promulgated to adjust environmental protection fee for industrial wastewater in Ho Chi Minh City. It increased 6-7 times the total wastewater fee for industrial zone in Ho Chi Minh City. So it's a very good opportunity for us to use this framework to analyze to what extent the industrial zone can change their capacity to respond to these economic instruments in order to help them to achieve the goal of water efficiency at the wastewater levy outflow. There are different strategies which industrial zones can follow to respond to the levy. However, for each strategies, we saw the role of institutional capacity influence the way they respond to this levy to achieve the goal of water efficiency innovation. Whether they decide to bear the cost, sharing the cost with enterprise, or avoiding the payment for the levy by processing water efficiency innovation. The third highlight, we focus on understanding the improvement of government capacity during the design of involuntary instruments, the EIP certification. This was published in Degree 82 of the government in 2018. We found the benefit of the certification beyond the effect on the end user or around the practical arrangement that it own for capacity of the government are improved. We also see the chronological and cumulative effect related to the design process of EIP certification, as well as the interaction among different capacity. To conclude, institutional capacity is a valuable approach to support not only industrial zones but also governmental organizations in order to follow water efficiency strategies or to achieve other sustainable goals in the future.